I'd now like to welcome up to the stage Ted Norcott and Harry Bandahl from Fortis, and they're going to talk to us about hydraulic modelling with GIS data, I believe.
Thank you, everyone. Thanks for having us out this afternoon. Again, my name is Ted Norcott. I work at FortisBC. I work in the GIS department, and this is my colleague Harry Bandahl from the System Planning Group. So today we're going to talk about how we're using our Smallworld GIS data to build hydraulic modeling software, or data for the software, I should say. A little bit about FortisBC. You probably know us as Terrace and Gas. We're now called FortisBC. We're a subsidiary of Fortis Inc. We're now a combined utility of both gas and electric. So we're a little bit more dynamic now, I guess you could say. And we've got 2,300 employees. We operate, on the gas side, we operate approximately 48,000 kilometers of natural gas pipeline. And again, on the natural gas side, we have approximately 950,000 customers. We also have the distinction of being the largest, or having the largest territory of any North American gas utility. And similar to SAFE, we're also located in beautiful sunny Surrey. So if you're in the Fleetwood area of Surrey, that's where our office is on Fraser Highway. A little bit about our service areas. So you can see it's quite extensive. We've got the Lower Mainland over here, all the way up the interior of the province, as well as the Kootenay area of BC. We also operate on Vancouver Island, and as part of that regulatory area, we also cover the Sunshine Coast. And another division of FortisBC is our Whistler area. As you can see here, we have the Whistler pipeline running along the highway, and this is our distribution system for Whistler. So now I'm just going to hand it over to Harry, and he's going to explain his part of the presentation.
Good afternoon, folks. Here. Okay, as Ted introduced me, I'm Harry Bandahl. I work in the System Capacity Planning Department at FortisBC, which is a branch of engineering. So what we do is we do hydraulic modeling of our pipeline system, the 48,000 kilometers that Ted had mentioned. And basically, we're the fortune tellers at FortisBC. So our primary function is to do long-term capital planning. So we try predicting 20 years out, see what and try to figure out what our system looks like. Sometimes it feels like, I don't know if any of you played a game SimCity. It's similar to that. We just kind of play it. It's almost like a video game. And we also provide support to we provide support to operations, so planned and emergency work. So if our pipeline gets hit, we could simulate that in our model. Okay, so going back a couple of years, we were employing two different software to do our hydraulic modeling. So one was called Synergy Gas, which is for distribution systems. So that would be the gas being delivered to your homes, and it's at lower pressures. And a second system for higher pressure transmission lines. So these would be the big arteries coming from like northern BC, moving gas around the province. Okay, and so the two tools, we built the models using two different processes. So with the distribution system, we used CSV files, which were extracted from the GIS system using a custom-built application. And for our transmission lines, very low tech. It was hand-built schematics. So it didn't really make sense to have two different software doing basically the same thing. You had to maintain two different skill sets. Our licensing costs were also doubled. And there's also we were also facing the issue of one of our software needed to be upgraded because it was no longer supported by the vendor. And bottom line, it was going to cost us money. Continue employing two different software. So the solution, go down to one software, and that was the Gregg engineering software. It was deemed to be the most economical solution. But we have a problem. How do we build 48,000 kilometers of pipeline in a software which we traditionally built hand-built schematics? It wasn't feasible to build our distribution system, which is a huge network of like basically a big spider web. We were not even going to consider building it by hand. And then the vendor came to us, and for Gregg Engineering, they said, well, we could help you with this. We use a format called shapefiles, or a format called Esri shape. And, you know, like typical engineers, we try acting like we know what the hell, like we know everything. Except for when it came to this, we just all had a blank look on our face. We were like, shape, what the hell is that? And then we had to go to Ted, and FME came to the rescue.
Thanks, Harry. Okay, so we wanted to give you an example area, and one of my most memorable places to go in the province is, of course, Hope. Now, the reason why we picked Hope is that it's a relatively clean data set. The numbers are small. When I show you some slides here, you're going to see some of the results of the translations, so we'll be able to discuss some of the numbers there. And it's also a self-contained distribution model. So that's why we chose it. And it was also actually our pilot area when Harry and his group came to our department to get some help. So this is what Hope looks like in our GIS view. Okay, so we have distribution pipes. There's a series of fittings and whatnot attached to those. At this scale, you're not going to see them. But we've got some water features. We have a municipal boundary. And these are, of course, the list of objects that we have in our system, or at least some of the objects. And this is what the data looks like in Gregg. So basically what we're going to focus on today are the distribution pipes here. Now, as we all know, FME has become extremely dynamic over the years. I've been working with it since, I believe, 1997, and it's amazing how it's really come into its own. As a result, in order to process to the level of quality that Harry's group requires, we had to break it down into 7 steps, or 7 separate workspaces. The first one being export the data out of Smallworld. We found that when we're running processes within the Smallworld database, it can sometimes be very time-consuming. It takes a long time for the translation to operate. It also ties up a Smallworld license. So we found that the best step, especially because we're dealing with distribution, they're called network area models. So for example, Hope, it was more efficient to actually pull that data out and then work with it outside of Smallworld. So the first step, export the data into shape. Then from there we need to merge some address data. We then need to move our customer meter locations onto the gas main, because again we're building a hydraulic model, and I'll explain this in a little more detail shortly. There's a couple of QAQC stages at 4 and 5, and 6 we want to distinguish between our different customer types. So we have industrial as well as residential and commercial. And then the last step is to assign some work order information. So this is our first workspace. It's fairly straightforward. Ideally, this would be all Harry needs. In other words, Harry comes to me and says, Ted, I need some shape files. There you go, Harry. Smallworld, shape. Are we done? Unfortunately not. Harry's got a lot of requirements. So here is how we fulfill those requirements. Okay, now I'm going to go into a little bit more detail on these ones. So in order to basically create our customer points, we have something what we call our service meters, which is this object here. And then we also have an address component part of that meter. Now within Smallworld there's what they call a soft join. So they're actually 2 separate tables. So when we export the data out, we have to then rejoin that information. And so we're using the feature merger, which I believe was highlighted today, earlier in the talks. And if you haven't used it, it's an amazing tool. It's a great way to bring 2 databases together based on a common identifier. And so that's what's happening here. So we have the service meters have a service ID, and as well the address table has the corresponding service ID. And so we're just joining those back together. Next step is we're going to be extracting some coordinates here, and then we're going to test to see whether or not these are actually active customers. Because again, we're building a model. We don't want to have meters that don't have a customer attached to them. So what's happening here is we're doing a test to see whether or not that meter is in our CIS system or not. And the way we determine that is if the meter number is blank, then it's not an active meter. Or if it is assigned any of these other values. I'm not sure if you can see that from there, but it says not in CIS, and there's some different variations of that. So basically, we run the translation through, and these are the initial results for the meters. So we've got our green meters, which are considered in CIS or in our customer information system, and those that are not. Okay, so those are the two different data sets there. And I just wanted to show you this slide, because this is our desired result, because there's quite a few stages. So what we're trying to do is those initial meters that I showed you, they exist in this space in terms of the GIS. So they're not on top of the pipe yet. They're connected by a service pipe. So this is what you could call sort of the raw data. And then these lines are distribution lines. So what we're trying to do is basically move this meter to the main, so that it's actually attached to the main. And there's going to be other information attached to that service as well, which then, or to that meter, which then basically transforms it from a meter into a customer. So this is the what I call the big workspace, and I have to credit Safe Software. They were instrumental in helping me develop this workspace, so I extend my thanks to your team. In other words, when I was developing the requirements with Harry's group, I was able to get it to a certain point, but then I kind of hit a bit of a knowledge gap, and they helped me fill that gap. So I'm just going to go through and explain this entire workspace and exactly what's going on here, because this is really where the true FME power is being unleashed. So we have service meters with address now, because they've picked up the address from the address table. And then we have all the pipe information here. So we've got distribution pipes and service pipe. Okay, the next stage is we now have to then, of course, add value to that data. In other words, we need to transform that data in order to move it to the main that it's attached to. So the first step here is to actually overlay the meters with the service pipe, and from there we're going to be attaching a distribution pipe ID. So that's what's happening at this point as well as over here. And from there we are then keeping some attributes. So there's some attributes that we don't need. We're going to make sure that we have these attributes. So we've got a scenario number. So this is like work information, as well as our distribution pipe ID, which is very crucial in moving those meters. The next step is a spatial filter. And what we're doing here is we want to perform a test to see where those service pipes are actually touching the main. And we want to capture those XY coordinates. And that's what the spatial filter is doing at this point. So from here, we're now going to merge the information that we acquired from the connection point to the main. We're going to merge that with the service pipe. And we're also going to make sure that the meter IDs are also attached to those service pipes. So the result of this feature merger is that it actually identifies what we call our first generation pipes, or service pipe. Sorry, first generation meters. And those are flowing into this feature merger up here. Now, in our system, not every meter is attached to a single service pipe. In other words, you could have you could have a meter attached to a service pipe, which is then attached to another service pipe, which then attaches to the main. So that's what's happening in the next stage. We've got 52 service pipes, which are actually what we call second generation meters. And we have a third generation spatial filter here, which isn't being used. But for example, in areas such as Surrey, Langley, where there's a lot of, say, trailer park areas, there can be as many as 9 generations of these service pipes. So what's happening here is we're just making sure that we can capture, or we can pass all of that distribution pipe ID information to all of those service pipes. Now from there, we have the service pipes and the meters flowing into this feature merger. And this is where we're reassigning new coordinates to those meters. So basically all of these service pipes that are flowing in this direction are going to pass their connection XY coordinates to the main to the meter. Okay, so then we have a 2D point replacer. So this is where we're actually going to reassign the coordinates. So in other words, the original shapefile for the meters has got of course, the original XY coordinates. We need to reassign those, and that's what's happening with this transformer. And again, there's a couple of things happening here. We have those that were complete, so there was a complete feature merge, and then there were, unfortunately, we had a couple that were empty. So of course, what do we do with those? That means that they're not going to have their coordinates. Well, later in the process, I'll explain how we deal with any data errors, which in this case, we've had 2. And the error could be that the meter may not have a service pipe for some reason, or it could be that the meter is slightly disconnected from that service pipe, or the actual service pipe for that meter is slightly disconnected from the distribution pipe. So there's a few scenarios. Unfortunately, there's only 2, so they should be relatively easy to solve. So there's a little bit of attribute removal going on here. We're adding a sequence number. Another requirement from Harry's group is that every feature in the shapefile has to have a unique sequence number. So these are, again, this is another shot of that sort of our desired results. So this is what the viewer would pop up, and you would see that all of these are now relocated on the main. But of course, there's at least 2 of them that are empty. So we need to deal with those. So before we do that, we're going to do a little bit of QAQC. So this is on the pipe diameters. Now, like any GIS system, ideally you would have all of your data with all the proper attributes there. But unfortunately, in some areas, we have a pipe that has got the missing information, such as diameters. And this is what this checks for. Fortunately, Hope has got all the diameter information, but I just wanted to show that this is one of our QAQC files. And if there were any pipes without a diameter, they would flow into this diameter file here, or this pipes unknown diameter file here. We also want to QAQC our core customer, or our core customers, which would be residential, commercial, and industrial, basically all of our customers. And this is the point where we're going to solve those 2 meters that were not connected. So basically, we're going to do a point on overlay check to make sure that all those points are actually overlaying with the pipe. And as you can see, we've got 2622 that passed, and that actually were overlaid. Then there was a tester done here, and unfortunately, those 2 that we know about, they failed. So then, of course, we use that wonderful transformer, the neighbor finder, which would be really handy during a strata meeting, actually. When you're trying to get something passed and a couple of neighbors don't show up. I wish I could employ this for those special SGM meetings where you have to get something put through. So we use the neighbor finder, and based on a certain distance from the main, we're able to relocate or locate those missing meters. Now, there is some visual checking. I'm not going into a whole lot of detail because of our time constraints, but we do actually make sure that meter is within a proximity to the proper main. In other words, we don't want to be attaching it to the main on the other side of the neighborhood. We want to make sure that it's on on the correct one. So we do that, and usually it's within about 10 to 20 meters of where it should be. So it's been extremely reliable for handling those errors that we find. And of course, we go back to Smallworld and we clean up the data errors that we do find, so that next time we run the process, we don't run into the same problem. Okay, so then we have some attributes being removed. We're replacing the XY coordinates on these two features, these two meters. And we're renaming some attributes, and we're adding it back to the rest of the family here, and applying a new count so that they're all in the right sequence, and then outputting them as our core customers connected. So, okay, so the next step here, we need to separate out our industrial customers from our residential and commercial customers. Now, if you have any questions about that, Harry would be the one to answer. But basically, Harry's group needs to distinguish between the industrial, like high load customers, so we're talking customers that are consuming a tremendous amount of gas, versus a residential customer load. And the way we do that is that Harry, every year he provides me with a spreadsheet of all of the industrial customers, as well as their premise number. So that's a unique identifier for every customer. In other words, every customer has a premise ID. And what we do is we compare that premise ID in the spreadsheet to the core customer premise ID. And we use that, once again, amazing transformer, Dale and Don, excellent work here with the feature merger. And we're able to determine very quickly which customers are in fact industrial and which ones are residential or commercial. So as you can see here, Hope is not a big place, so there's only 3 customers that are considered industrial, commercial, and they get outputted into this file. And the structure of the files is exactly the same. The only difference is that now Harry knows these are the heavy low customers and everybody else. Last step, assign the work order information. So this is fairly straightforward stuff. We're just doing the usual point on line overlay. So we're just passing the work order information from the pipe to our other features here, which are stations and valves. Again, when you're going to build a hydraulic model, you have to know where your stations and your valves are, so you know, of course, where to turn the gas on and turn it back on. So that's what we're trying to do here, is just assign the work order information for those. And, of course, not very pretty, but these are all the shape files that we delivered to Harry's group, and they're broken down by network area. So there's approximately 50 models that we deliver, and this is the standard format. So we've got core customers, industrial customers, pipes, stations, and valves. And Harry, you can add to this conclusion as well. Basically, we're extremely pleased with the way that the workspaces have run for us. Shape is the desired format, so we're down to now one standard file format. And as Harry pointed out, they're using one hydraulic modeling software, so we're able to save money there. And we've had excellent support from Safe Software. You guys should give yourselves a hand. I try every day to use your product as much as I can, and I have yet to be let down. So well done, and look forward to doing more projects with it. And Harry, do you have any last conclusions?
Yeah. I just want to point out again, we saved money.
Yeah. Yeah, of course. Management loves to hear that. So some future plans. Of course, we want to automate the process. I was talking to Dale a little about this before the presentation, that I'd like to chain all of those workspaces together. I mean, it's quite possible we could put this all into one massive workspace, but I think we need to maybe just break it down and maybe join those together. And then another plan is to put this entire system up on FME server, because we have FME server, and make it a self-serve option for our system planners. And that's it. Any questions? Jonathan? Yeah. Maybe, can you answer that one? You're talking about which identifier, the premise ID or the pipe? Oh, the counter. Yeah, maybe Harry can answer that one. You're talking the sequence number? Yeah.
No, we're just.
Go ahead.
Yeah, we're not concerned with that. The main thing that we have to carry over from year to year is the premise ID, and that ID never changes. It's yeah, we don't recycle those numbers. If we lose a customer, we basically will abandon that number and never gets used again.
So the number, the sequence number is just based on the requirements from the hydraulic modeling module?
Yes, yeah, and we rebuild our models every year, so that's not an important field.
Any other last questions? Okay, thanks.